today we're going to work backwards and kind of be able to take information from a four-sided figure. And if we know some specific things about our four-sided figure, then we can conclude that they are parallelograms. So we're going to work backwards. We're going to actually take some diagrams and decide if they are parallelograms or not. And then from there, once we know that, then maybe we can use that and the ideas from yesterday to gain more information about it. These first two ideas are things we can use to explain why two figures must be parallelograms. The first is called the parallel sides converse, and it's and it says the following. It says that if the opposite sides of a quadrilateral are congruent, then it is a parallelogram. Okay, so if you have a four-sided figure and you know that the opposite pairs of sides are congruent, then that figure is forced to be a parallelogram. So if we get opposite sides of a quadrilateral are congruent, then we know it must be a parallelogram. Similarly, we'll take that other part, that other theorem from yesterday, is converse is also true. So that if opposite angles in a quadrilateral, I'll abbreviate it for you, are congruent, then the figure is a parallelogram. And those two theorems yesterday we said if it's parallelogram, then we know some things about its sides and angles. If you know something about the sides and angles, then we can actually conclude that it must be a parallelogram. What's nice about knowing that it's a parallelogram? What more do we gain just by knowing it's a parallelogram? What else do you know about the sides then, if it's a parallelogram? Okay, what if I already know they're congruent? What more does this gain me if I know they're a parallelogram? What is the definition of a parallelogram? Two pairs of parallel sides. So if you know a figure is a parallelogram, then the next thing you could conclude, or the next nice piece of information, would be that then you know that these things are forced to be parallel. Would be nice. Okay? So if I knew something about parallel sides, if I asked you a question about parallel sides, it might be a good idea to show that, say, a four-sided figure is a parallelogram, and then you get a bunch of like parallel sides going on, parallel segments and lines and stuff. And I can tell that none of you had B for geometry earlier, because this word right here, just some people came in almost crying when they looked at the notes. Okay. I don't know what your instructor said in first trimester, but a proof is nothing more than just explaining why this is true. So we're going to explain with some evidence why this thing is going to be true. So for example, we're going to actually together, your homework won't be, so to alleviate your fears, your homework is not going to be centered around lots of proofs today. However, just because your homework doesn't have a ton of proofs doesn't mean you shouldn't ask, well, why is that work? Why is it true? Why should this actually come out? So I want to reason you through exactly why this needs to be true. And the parallel sides converse, again, it says that if we know opposite sides of a four-sided figure are congruent, then we know they're parallel. Okay? So we're going to start with just a diagram where we know that we have this figure. We'll just draw a little figure here. And let's even try to make it look. I'll call this like A, B, C, D. And all I know about this thing is that that AB is congruent to CD, and AD is congruent to BC. That's all I know about this diagram. And I'm going to eventually try to conclude that this must be a parallelogram. Okay? The trick to this, to explaining why, is let's draw a missing segment here. Let's draw a diagonal. How about this diagonal from B to D? By doing that, what have I created? Two triangles. Okay, so my explanation will go as follows. So let's say, if I'm here, what do I know about? Say the two triangles that I just made? Right? Okay, so they're going to share this. So then, moreover, what do I know about these two triangles? Congruent. So from the given, here I know that triangle ABC is congruent ABD is congruent to triangle CDB. Why are those two triangles congruent? Side, side, side. They're congruent because of side, side, side congruence. Shared two sides, congruent, and a reflexive third side. So these triangles must be congruent by side, side, side. So from there, what more do I know? So all the angles are congruent. So what would be like so then, let's maybe, before we start picking angles we want to be congruent, let's think a little bit ahead. We want to show this a parallelogram. So what angles do we want? What angle pairs do we really like to be congruent? What would help us there? If we could get, say, a couple of these angle pairs to be congruent, what's that going to tell us? For example, we do know that angle ABD, so how about this be like almost a paragraph here. Therefore, angle ABD is congruent, ABD is congruent to CDB. Why are they congruent? Okay, that's the next step. We know they're alternate interior, but we only know that alternate interior angles are congruent if you have parallel lines. So we don't know we have parallel lines yet. That's actually, we're trying to go the other way. You have congruent triangles. What do you know about all the parts of a congruent triangle? They're congruent. So what do we say if we have congruent triangles? How do we say other parts are congruent? Corresponding parts of congruent triangles are congruent. CP, CP, C. Corresponding parts of congruent triangles are congruent. Corresponding parts of congruent triangles are congruent. CP, CP.
Oh, yeah, you said CP, CTE.
Equal, sure. Sure, there. Equal in measure or congruent. I didn't screw. Okay, it's all right. There's a lot of ways you can do it. Also, by that same reasoning, then these two angles must be congruent. Then what angle ADB is congruent to angle, CDD, for the same reason. Okay, we have these. Now, I think, was it Reese said that, oh, these are also alternate interior angles. What do you know about two lines if their alternate interior angles are congruent? They're parallel. So since angle ABD and CDV are alternate interior angles. Therefore, AB is parallel to CD. AB is parallel to CD. And why are they parallel? Now you gotta go way back to like chapter, I think it was 3, when we talked about parallel lines. What's one way to show that two lines are parallel? And we have it right here. Yes. If alternate interior angles are congruent, then the lines are parallel. Because the alternate interior angles are congruent. What other lines need to be parallel because of that same reasoning? AD and BC.
Yeah, we already know that if you're saying you're doing and you're saying like first you started that they were parallel. So if they're parallel, then they would be like in the sides would be congruent. So like the sides would be congruent.
So also those are parallel by the same reasoning. Is now, since you have two pairs of parallel sides, well, that's exactly what a parallelogram is. Since we have two pairs of parallel sides, therefore, A, B, C, D is a parallelogram. Two more ways to explain why we have parallelograms. Hold on, I gotta make sure I'm good here. This is the dissecting diagonals theorem is just the converse of the theorem we had yesterday. That if the diagonals bisect each other in a quadrilateral, then they're congruent. I want to make sure I have this one off the top of my head. The two theorems say the following. The congruent parallel side theorem says that if one pair of sides in a quadrilateral are both parallel and congruent, then the figure is a parallelogram. So if you're given this piece of information, it's four-sided, you have one pair that's parallel, and that same pair is congruent, then you get a parallelogram. You could, the proof of that would be pretty similar to what we had before. Draw a diagonal, make yourself two triangles, show the triangles are congruent, then force the other sides to be parallel. The last one is the converse of the diagonals theorem, which is if in a quadrilateral, if the diagonals bisect each other, then the figure is a parallelogram. So more or less what we're seeing is that those ideas we talked about yesterday were more or less if and only ifs. So if you get one way, if you say that the diagonals bisect each other, it's a parallelogram. If it's a parallelogram, then the diagonals bisect each other. The same with the front side. If opposite pairs of sides are congruent, then the figure is a parallelogram, and vice versa. If it's a parallelogram, then they bisect. Then they're opposite sides are congruent. So a big part of today is going to be giving you a figure and then deciding if it could be a parallelogram or not. Knowing what information you would need. Knowing what information you would need to show it's a parallelogram. Say, for example, find the value of x here that makes this figure a parallelogram. 7x plus 5 goes along with this side. 3x plus 17 goes along with this side. So what would we need x to be? What has to be true if this is a parallelogram? Yeah, we need these diagonals to bisect each other, which means we need each of these parts to be the same. So we want to pick the x that makes 7x plus 5 equal to 3x plus 17. Okay. When you pick the correct x, when you pick the x that makes this true, then this figure is forced to be a parallelogram because the diagonals will bisect each other. Or if you get, 4x is 12, x is 3. If you choose x to be 3, then this becomes a parallelogram. Similarly, what should be true about this angle pair if this is a parallelogram? Those things better be supplementary if this has any chance of being a parallelogram. If these are supplementary, then we get parallel lines, and now we're on our way. So we could say should be one equation that we should be able to set up to figure out what x is. Okay, so this, I think on here, well, let's see. We're going to try to, I'll even give you, yeah, we're going to find x to make it a parallelogram, so you can give it a chance. I'll even tell you, throw in a little bit of information that this is probably necessary as well.
Yeah.
To show this.
I did. No, I did like. Just wait.
Okay, so how would I explain why each of these are parallelograms? So, what would I use to claim that these are parallelograms? Why is this forced to be a parallelogram?
Because opposite sides are
Opposite sides are congruent. I think this was the converse of the parallelogram sides or something. So just opposite sides are congruent. Therefore, it's parallelogram. How about B? Why is B parallelogram? And why is C a parallelogram? Pair of congruent parallel sides. That would be my explanation of that. That figure has that quadrilateral has one pair of congruent and parallel sides. Therefore, it's parallel.